Hello, and welcome to Supply Chain Next. I'm your host, Richard Donaldson. Join me as we explore the ongoing evolution of supply chain, from the challenges practitioners face every day to the ongoing digital transformation of the entire value network.
And good morning, and welcome to the next episode of Supply Chain Next. I am excited this morning to have Bill Shevlin from Santa Cruz and CEO of Microgrids here coming on this morning, Mavericks Microgrids, which I think, and again, I'm going to ask you the random question already, Bill, is Mavericks akin to the Maverick surf site since it's just up the street?
Yeah, we named it after that, because it's one of the most impressive, powerful waves on the planet that we know of. And, it's continual and it doesn't stop. And, we're going to create a wave of energy that washes over the U.S. with our microgrids.
I love it. I had to start with that very first one. So welcome this morning. I know it's early in Santa Cruz. Appreciate you getting up and kind of get going with me this morning here. So let's just dive right in. Would love to hear a little bit about, kind of your history and background, because it's pretty interesting bringing you all the way to where you get to Mavericks Microgrids. But yeah, we'd love to hear a little bit, just the opening around who Bill Shevlin is and how you kind of got started and how the beginning of your career began. Sure.
Yeah, no, I appreciate the time, Richard. It's great talking to you and being on the podcast. I started out in my career in real estate development and management. We built buildings mostly in commercial and office, retail, and always built around the efficiency standards in the industry. And in 2008, 2000, I think, joined a company that was focused in commercial roofing. And we went out and we utilized energy efficient roofing, which is now referred to as cool roofing. I actually went out and worked with the California Energy Commission, Lawrence Berkeley Labs, to prove that it saved energy. We did some calculations on it, and we would sell roofing based on a return on investment, which was different. We also developed some of the initial rebates, and a lot of what we did became Title 24 standard in building envelopes throughout the U.S. From there, I actually worked with a national company, and we developed a solar program back in 2008, 2009. We used to do a lot of corporate national accounts for Walmart, Kohl's, Marriott's, companies like that, where we did on-site energy generation, offsetting customers' bills. We'd essentially go in, figure out how to decarbonize their portfolio before people really knew what that meant, and also reduce their energy costs at the same time by putting renewable assets on site. One of the issues that I had with that was always working with the utilities and dealing with the long delay of being able to connect that solar project and feed it into the grid so we could offset that meter. And when I first started installing solar commercially, the costs were about $8 a watt, and they got down into about the $1.50, $1.75 per watt range. And I saw batteries doing the same, following that same expense curve. And so I really, 2018, really took a deep dive on the microgrid space and looking not just at the technologies, but what was going on in the markets as far as what was going to be taking place that were energy intensive uses. Obviously EVs were a very energy intensive uses, data centers, and controlled environmental ag. And so that's where we spent a lot of our initial focus. Now we're really focused on decarbonizing a site, but using that strategy to also decarbonize vehicles and transportation, which means that we can touch the entire supply chain by offsetting a customer, creating strategies for them, and then implementing those EV technologies. And even in some cases now we're talking about larger sites that will generate hydrogen, and then we can offset the supply chain on the hydrogen side as well.
Mm-hmm. So, and as you said, and I want to kind of highlight a couple things going back through that. Are you a lifelong resident of Santa Cruz? Let me just sort of start there.
Yeah. Grew up around here, and a lot's changed since I grew up there. It was really a beach town versus a hub of Silicon Valley now.
Absolutely. And with that, then kind of my you said, and you're absolutely right. You were you were quite a bit ahead thinking about sustainability in the context of roofing and building materials and things of that nature. And so is that also kind of a result of being in the environment that you're in, or is that something that you always kind of just naturally fell towards?
Yeah, you grow up in a community like Santa Cruz where you can be in the redwoods in 15 minutes in the ocean, on the opposite, or we can drive an hour and a half and be in the Sierras and be in the snow. Always grew up around the environment. When I was a senior in high school, actually was involved in a program that we went out and we taught Special Olympics athletes. We built ropes courses. We learned how to rock climb. We were really out in the environment a lot. And, so growing up around that, wanted to make sure that what I was doing made an impact, but also really, really good at math from a young age. And so, I saw the cost benefit of saving energy. Really started out in the efficiency space and then got into the renewable space, because what we've seen and what we're continuing to see is when we work at a site and we provide energy infrastructure, we can deliver power cheaper, faster, better than the utility, and we can do it cleanly. And we can get really good returns on it that then allows us to sell some of that excess energy to the grid and do a lot of different things. What we're kind of right at the forefront of in the transportation and electrification market is really decentralization and the digitization of electricity is really where we're at. It's one of the last remaining infrastructures that hasn't been upgraded.
Right. Well, and then let me, and this is another thing, and I'm kind of drawing a little bit on my former experience in the data center space, a lot of energy consumption. But you also hit on a point that a lot of people, I don't think they're maybe casually aware, but they need to understand is the grid itself. Oh my goodness, is what, 60, 70, 80 years old in some places? I mean, it's sort of like plumbing, where we take it for granted till it breaks, but the grid itself is extremely archaic and, it needs a lot of upgrades.
Well, and there's no visibility to it right now. And what I mean by that is in a computer network, you can see what's going on. You can see where the traffic is. You can see if you have an issue with the network. With electricity, we really don't. There's no visibility into the greater grid. And if a section goes down, the way that they go and they find it is that a person drives out in a truck. They look at the lines, and they will manually, when they have to turn something on and off, they have to manually climb up the pole or get a hook and turn a switch on and off manually. When we install a project, we have to use new technology. We have to use stuff that we can monitor every panel. We can monitor the cell on the panel. We can turn the entire system on and off remotely. We know exactly what's going on. And the utilities haven't made those investments into the grid like most energy companies have of today.
Yeah, right. And so again, I think that's also a key point to this is, it's like roads, or again, I go back to plumbing and sewage. I go this core infrastructure, which a lot of people take for granted, is honestly quite old, right? And it's expensive to change, but it needs to change. But it's a long time coming. It's kind of like sustainability. You've been talking about for 30 years. We should have been doing this 30, 40, 50, 60 years ago. But for some reason, humanity is fairly slow, but whatever, we'll leave that aside for a second. Usually it requires
that could be a long conversation right there.
Yeah, right. I don't want to get too far into that one, but let me go back to, because you also talked about it, you kind of flew over it, but you were in like housing and commercial real estate, and the first thing that you started to focus in on were roofs, sustainable roofs, if I'm not mistaken, right? Kind of early in the career. Like, why roofs of all things versus solar panels or alternative energy sources or something? I mean, what was it about roofs that made you kind of get into it?
So we did efficiency within buildings, and we would upgrade HVAC and lighting and such. But what we found is, and this is 20 years ago, where most roof systems were asphalt. Well, think about an asphalt parking lot when you walk across it. It's when it's sunny out, it's 30, 40, 50 degrees above ambient. Well, roofing materials were always traditionally built out of the same material, so that the building would get really hot, and that heat has to go somewhere. It goes inside of the building. if you use a reflective, emissive material that stays cool all the time or close to ambient, that heat never has a chance to go into the building. And when we did some of the initial studies with the California Energy Commission, they actually came out and put sensors on the building, sensors on the HVAC, and in some cases, we had 50% savings on cooling costs in those facilities. Mm-hmm. So we could do an HVAC upgrade that would get maybe 5, 10, 15%. But when we did the envelope, we realized sometimes a 50% savings, and that was a huge kind of aha moment. And then we utilized that to build additional upgrades. We would daylight buildings, so we'd put in skylights, we'd put in lights with sensors, trying to cut down those energy costs overall. But also it also increases the health of the building, the longevity of the building, the life cycle. There's a lot of cost add benefits when you put in infrastructure correctly, whether it's a roof system or a microgrid infrastructure.
Mm-hmm. So, okay, perfect. And then that experience, right, kind of built from pun intended, no pun intended, but built into or kind of springboarded into your platinum companies, which looks to me like that was sort of the precursor to what you're doing now in the microgrids, right? The Mavericks Microgrids. But talk to me a little bit about that, because it's, energy efficient projects that you morphed into something, spending a good deal of time here too. It looks like 7-8 years.
Yeah. So when we started doing solar, I actually worked at a national company, and we had clients all over the U.S. And mm-hmm. my region was Western U.S., and that's right when solar was kind of taking off. And we had all these national accounts, and we started getting a lot of calls from the accounts, but also from a lot of the material manufacturers that we worked with, complaining that solar companies were coming out and creating warranty issues. Mm-hmm. And so we actually ended up being an installation partner for multiple solar companies, because we could go out and we could install the solar on a roof or in a facility and do it in a way that didn't void warranties, didn't damage the buildings, because we knew how to build things quickly and efficiently. And so we became an installation partner, and then we ended up launching a national solar division. But at the time I was traveling a bunch and my kids were younger, and so I got a little bit tired of that. I got offered a position at a local Bay Area company to come in and join them. And we basically bought him out. We built the company up from a few $1 million a year to $30 million within about a 3-year period of time. Wow. And, during that time, I also developed about 8 different patents to be able to attach solar to roofing structures and buildings. Mm-hmm. And we essentially did it in a way that utilized the existing building materials. So it was mm-hmm. integrated with the systems that were already on the buildings, didn't void any warranties. And it also cut our installation costs down. So we were able to, again, do it cheaper, quicker, faster, better than a lot of the competition.
Right.
And, we at one point in time, we were installing about 1 million square feet of building envelopes, insulation, upgrades, and solar on these facilities a month. Mm-hmm.
And let me jump in. So there's a larger strategic play here, and I'm going to sort of connect the dots at a very high level, right? And I see this in your probably colleague or semi-counterpart or brethren, Elon Musk, in what he's doing with Solar City and whatnot, right? And so in my head it is, you're talking about developing alternative, sources of energy. In this case, solar. We'll focus on for the moment in the home, and then pushing that energy back to the grid where it's stored and distributed for general use, right? Okay. But going back to the whole concept of the infrastructure is old and needs replacing, there's not a very good way to do that wholesale without incrementally going, ironically, from the end user, creating and generating power, and then starting to push that back onto the grid, and then starting to replace the grid incrementally, leading to what could be called microgrids.
Right.
So again, there's a hidden and not so obvious or kind of semi-obvious question in there, which is, did you start to see the dots connecting on how to do a wholesale infrastructure replacement through solar panel installations in homes and yada, yada, yada. Go ahead. Yeah.
Yeah, that's actually one of the reasons we're so focused on the space. And so if we look at one of our example clients, so we work with residential all the way through commercial, industrial, and even municipalities.
Mm-hmm.
So on a like a food processor site, so we have some food processor clients. They use a lot of energy, but they are seasonal both by day and by year. And what that means is that they have really high uses of energy and they have really low uses of energy. And so what we do is we build a system that can create that energy at the high point, but has excess energy at the low point. So we have that available. The other issue with a lot of people right now, whether it's at your home or in a commercial industrial building, is the utility can't get the power there. So we're in California. Now I'm in Northern California, which is PG&E region. Everybody hates PG&E because they're starting fires and turning off the grid all the time. We have customers that have been told by the utility that they can't get them power upgrades until 2025.
Right.
Now, these customers want to convert some of their vehicles to electrification. And in some cases, they have fleets of 1,000 plus vehicles that might be a small pickup truck all the way through a semi truck. And when you think about a site that needs maybe 100 vehicles that are somewhere between 100 kilowatt and 500 kilowatts worth of energy, you're talking about a small city at that location. Well, we need to be able to put all the energy generation, the energy storage, and everything else on the infrastructure basis that can charge those vehicles and supply power to that site. When those vehicles are not being charged, or the facility is, in its low energy usage during the evening or in the off season, we can sell that excess power to the grid. We can actually virtually net meter it and sell it to other customers. And if you do enough of those, you can actually create grid support in a region. You can do a lot of different things. So, you talk about Musk, that's kind of one of his plans, where recently Tesla just got approved to do energy trading in Texas.
Right.
Essentially, they're deploying a whole bunch of batteries. They're essentially selling power in between these batteries and in between customers. We're using the same strategy, but we're focused on the customer site, providing power at that site. And then, we create additional monetization by selling that excess power. But when we do it at the site, we're essentially decarbonizing their site. And because we're charging their vehicles, we're decarbonizing the supply chain at the same time. So if that, in the case of an ag customer, when they're taking their vehicle and they're going out to the field to check that field, if it's ready for crop or it just needs an inspection, that small pickup truck can be powered by EV that's powered by the site. If it's a fleet truck that's doing local route, same thing. So now all of a sudden, what we're doing on the electrical side, and we have a dashboard reporting system that the customer can tie into, and they can see what their carbon footprint is. They can see what their energy usage is. And just on the energy usage side, we typically save customers 5 to 10% at their site. Within fuel savings, we can save 20 to 30% because we can generate electricity much less expensively than they can buy fuel. The other thing that we do is we fix that cost over a 20-year period of time. So if you think about it from a operational perspective, they've got a fixed cost of energy and they've got a fixed cost of fuel for 30 years. What's the fuel cost been over the last 12 months? It's been crazy, right? It's up and down. It's all over the place. I mean, here I just paid, I think, $5 a gallon in my combustion engine vehicle. So it's, so we're doing a lot of different things in that space. We're actually working with a development company that's doing 3D printed homes.
Oh, wow.
We have a project in Virginia coming up that's 200 homes. We're going to be building a microgrid or a virtual power plant for the home. So each home will have solar storage and EV charging. So, we're going to, and we also will have smart circuit breakers for the home. So the homeowner will know exactly how much energy is being used. The energy in the vehicle that's traveling down the road will be provided at a lower cost than what they can get their fuel for. It'll also keep their home on all the time. So in the case of an emergency or a catastrophic event, the community itself is within a microgrid, but each home has a certain amount of storage and energy generation itself.
Right.
So they're each independent, but it's interdependent as well.
Right. And so great segue for me. So I want to kind of focus in on the concept of a microgrid, because again, you kind of flew over it. And the term is being bandied about quite a bit these days.
Yep.
It's not complicated, but I'd love to hear your definition so people can understand exactly what is a microgrid and why is that important today.
Yeah, so the microgrid really has multiple components. It has a controller, which essentially is watching everything that's being generated. Typically, it has some energy storage, and we design systems so that we're what's called behind the meter.
Okay.
So what that means is we have our own control system, we've got a battery system, and then we've got energy generation assets behind that microgrid controller. That microgrid controller and the battery are tied to the outside grid and the inside grid. On the inside grid, we have energy generation assets that may be wind, solar, fuel cell, waste to energy, really doesn't matter. But what does matter is making sure that we know what's going on within that system, optimizing the load and providing the energy over time. These really good microgrid controllers, not only are they built by large companies that have been in the electrical infrastructure space, but they also have a fair amount of software, machine learning, and AI to them, so that over time they can learn the patterns of not only the energy production, but the usage of the facility, the usage of the vehicles, and they're able to optimize that load. What I mean by that is if we have solar, the system will actually look at the weather pattern, see if it's going to be extra cloudy the next day, make sure that the batteries are charged up. Depending on the energy assets that we have in that, it may use fuel cell for part of that day, or it may use another technology for part of that day to build some of the base load, or it may just use energy storage where it's putting more energy into the storage that day, so because it knows it's going to have a deficiency the next day. So there's a lot of controls. And so if you go back to our original conversation around the grid, the grid can't do that.
Right, absolutely. And so let me go back, and I'm going to sort of rephrase what you just said. But a microgrid, at the end of the day, can be something. It is a small, grid onto itself, and it could be as small as a form factor as a home, right? I don't know if we get smaller than that, but the elements are: you need to generate power, you need to store power, and then you need to be able to deliver power back to the primary grid. I mean, if I were to sort of couch what a microgrid is, right? But it could be as small as a car. I mean, technically, I could probably look at a bike and someone biking, and that could be a microgrid because they're generating power. Maybe there's battery storage on the bike, and you plug it in and push that power back to the grid. But so microgrids themselves are in a way of kind of, instead of doing this large infrastructure, east-west United States build out, is actually go out to the end users, right? Develop these microgrids, start to deploy them, and in effect begin to backward upgrade the grid itself. Because what you're describing as well too, which I think is also a lot of people don't realize, is that solar power. A lot of times we put these solar panels on, and we're generating today way more power than we can consume in our home. So instead of letting that power go to waste, you store it somewhere and then deliver it back to the grid, just like you're describing, right? But that could be solar, that could be wind, that could be, whatever. It's just you happen to be focused on solar and I guess wind right now. Is that correct?
Yep. And then, the other thing about it too is if you have enough microgrids where it's really just this little independent mini grid, like you described, if you have enough of them together, you can sell power in between them, and that becomes what's known as a virtual power plant. And you can do a lot of different things in that aspect. And, we're kind of in a space right now where the technology is ahead of the legislation, just like always happens.
Go figure.
20 years or so. So a lot of times we have to play catch up. We work with a couple groups that work in the European markets, and the European markets are really kind of decentralized already, where they have a lot of community-based grids, and they're able to do a lot of virtual net metering and virtual power plants much more easily than we can here in the U.S. There's a lot of regulatory compliance where you have to go, if you want to be able to sell power through the grid, Obviously, you have to pay transmission fees, but you have to get all kinds of approvals to be able to do that, and it's it's kind of a long, arduous process to get to that point. There are some technology partners out there that are kind of going out and paving the way to get that pre-approval, so you can just onboard your energy assets into those systems, so that you can just almost plug and play energy is where it will go in the next few years.
Yep. Now, okay, so then that brings us actually kind of forward into Mavericks Microgrids, right? So that's a relatively new venture for you. It's all the things that we've been talking about. And as of right now, maybe you can just help us, describe a little bit, kind of what you guys are focusing on. Is it homes? Is it commercial? Is it all of the above? What's the core technology that kind of sits in there? Because it's a compilation of all these things. It sounds like you got some stuff on how to efficiently capture energy from the sun. I'm assuming you also have some ability to store all that, right? Yep. And then obviously deliver it back into the grid. So I'll let you. Expand on that.
So our company, we are agnostic on the technology somewhat, and what I mean by that is that, and I've always been kind of agnostic, but we don't have one preferred panel. On solar, for example, but we use what's known as tier 1 panels. Those are panels that have undergone a certain testing rigor. They've been proven. They have accelerated aging studies. We know what they're going to produce over that 20 to 30 year period of time. They're a warrantable system. Same thing with energy storage or wind or fuel cell. Whatever components we use within the system, we're fairly agnostic. On the technology side, we have a microgrid control partner that we use. That's a large electrical manufacturer. But we put kind of our own special sauce in it, in that we have some technologies that improve grid efficiency. And also, we're doing things a little bit different, because we're not just generating the electricity, but we're going all the way out through the vehicle and the facility. So we've got some smart panel technology that enables us to see what's going on energy usage within a building or within a vehicle, and match those loads and know what those loads need to do over time. So that's kind of what we do. But one of the things that really makes it possible is that we use consumption to be able to finance those mechanisms. And what I mean by that is, if we look at a facility that maybe uses $1 million a year worth of electricity, over a 20-year period of time, and this is typical across the U.S., most utility companies will raise rates 5 to 6% a year. So that $1 million today in 20 years is going to increase 6% annually every single year. So the
and compounded at that. So all of a sudden, what you might straight line at 20 million turns into a $40 million, lifetime.
Exactly. So it's a fair amount of cost, and it's typically a cost that a customer doesn't think they can control.
Right.
Well, what we do is we actually use the mechanism to be able to control that. And what I mean by that is that we look at that $1 million. We know how much energy is being used out of that, how many kilowatt hours are being used out of that $1 million, 15 cents, 10 cents, 5 cents a kilowatt hour, whatever it is. We reverse engineer how many kilowatts we need to develop on the site. We look at the highs and lows of energy production, figure out what the maximum is, what the minimum is, and design systems to be able to hit those profiles. And then we use different types of financing. We use investment tax credit, which has been used in the energy space for a long time. We use other mechanisms. We're actually working with a group right now, raising some green bonds for some of our projects. Right now there's also a lot of carbon offsets available and other potential carbon credits available that we're utilizing. So we kind of stack all the different finance mechanisms, and then we provide that power to the customer instead of $1 million, it might be $900,000. And instead of a 6% escalator, it's going to be a 1 to 2% escalator over time. And in some cases, if we're selling it at $900,000 per year, but we know that we're going to create excess energy on top of that, excess revenue, we actually can give the customer a rebate off of some of that excess revenue, so it can drive that $900,000 maybe down to $800,000 per year or lower, depending upon the system. So it's really, we work in partnership with the customer because we're going to be there for 20 years providing energy and energy infrastructure for them. So we want to make sure that not only what we're doing today works for them today, but works for them over that 20-year period of time. And so, we try to future-proof what we do.
Which makes total sense. So let me dive in on two things. One, you also mentioned carbon credits. That's an interesting topic right now, in the sense that carbon credits have been around for a while. They kind of missed the mark about 10, 15 years ago when they first kind of came on the scene. And so they're, in a way, they're being reintroduced. Let's call it carbon credits 2.0 or 3.0 or whatever you want to call it today. How do you view carbon credits in your work? Is that something that you guys sell? Because you have what a lot of people look for in true carbon credits, which is a direct path to sustainability or alternative energies. It's a self-sustaining project that's being invested in, meaning, you got 20, 40 year life, spans here. You're looking at homes. These things aren't like forests or things like that could be planted, but then, cleaned out later. So you've got a lot of what goes into what we're now calling high quality or, verified carbon credits. But let me stop there for a second. How are you guys looking at carbon credits? Do you use them directly? Yeah.
So, we have, we have like credits and offsets, so within what we do on if we're developing energy on site and it's renewable, and, so we do renewable and we shoot for always on renewable, which means that we're 24/7 renewable. That's a strategy of, solar's great during the day, but during the evening, it doesn't do so great. So we have to balance what we do. And, so every kilowatt hour that we generate, if we're totally carbon neutral, like here in California, the average kilowatt hour is about 9 pounds of CO2 because we're not 100% renewable in California. About half the energy we get is carbon intensive. In an area like Virginia, the kilowatt hour is about 2 pounds per kilowatt hour. So in the example of the home projects that we're doing down there, we're projecting that each home is going to use about 12,000 to 15,000 kilowatt hours per year. That's 24,000 to 30,000 pounds of CO2 offset that's affected by creating the right energy strategy for that home. So that 30,000 pounds, that's about 15 tons of CO2 offset in the market. There's markets available right now for those offsets. And, you can go out and you can sell them for anywhere between $15 and $50 a ton, depending upon the markets that you're in. The other thing is right now is there is some legislation in California, Massachusetts, Oregon, and Washington around vehicle electrification, because on a per mile basis, just in a consumer vehicle, it's about 9 pounds per mile of CO2 on average if you convert a vehicle from gas to electricity. And that's based on average mile per gallon of vehicles in the U.S. So there's what's known as low carbon fuel standard credits available in all those markets, and it's kind of going into other markets as well. But we kind of take that strategy on the energy side, but also on the vehicle side, combine those offsets, and we can sell those into the markets. The other thing that we do is on larger projects, we have waste to energy projects that generate what's known as carbon negative power. Now, the way that works essentially is we're taking a waste product, and that waste product could be biogas from a waste treatment plant. It could be digestive from a dairy farm. It can even be woody biomass. It can even be tires in some situations. So we're taking that product, and the systems that we use are typically pyrolysis or anaerobic digestion in that case. And what they do is they essentially heat that biomass up, or they heat that product up to a certain point, and they combust it. But they're super efficient in combustion, where they don't allow that CO2 to escape. So we're essentially recirculating that exhaust gas so that it burns. It creates heat, which we utilize. It creates electricity, which we utilize. And then it actually typically creates byproducts. If it's a pyrolysis system, it'll create a biochar byproduct. If the input is so there's a company that we know that they take bamboo and convert it into biochar for plant materials. And
when you say, sorry, just so I can ask the question, biochar specifically though, right, which is obviously kind of, I'm just imagining kind of this black mass of stuff because it's just been burned. What do you do with the biochar?
Yeah, so biochar, if it's derived from a plant material, they will use it into a plant nutrient.
Okay.
It can go into soil, and it has a super interesting structure in that a very small piece has a real large surface area. For plants, what that means is there's a lot of nutrients. So you're essentially taking, let's think about a ton of carbon-based material and combusting it and basically capturing all that CO2 and concentrating it into about 10% mass. So 1 ton, you can make like 200 pounds of biochar, but that means that every pound has about 10 pounds of CO2 in it almost, depending on what you're utilizing. That carbon, when you put it into the ground, it'll sequester that into the soil permanently. And they've done a lot of studies around it where it'll increase plant nutrients because it's got that structure. So plant nutrients are able to bond to it. You can reduce water usage. And most importantly, you're able to sequester CO2 using that. And that's one of the ways that it gets to that carbon negative manner, because you're taking a fuel input and you're gaining energy out of it, but you're also gaining a product that, increases the health of the environment for the plant.
Right.
Right. If you're,
So I was gonna jump in for a quick second because again, so much stuff is going on here, and you're at the forefront of so many things that people. Well, we've been talking about for a long time, but now people are taking much more seriously. So as you are now kind of developing this and pushing this biochar, talk about circular. Right. This is the ultimate of circular economy, right? Where we're trying to kind of, if we pull something out of the ground, you want to use it until it literally there's nothing left, or you're putting it back in a way that, like you just described, is biochar, right? It's actually very healthy to the ecosystem. Right. Right. And so I still think we're learning a lot about what that means though. Right.
Yeah, we are. And, it's interesting though. We work with a lot of companies that are bringing these technologies from the European market. So when we talk about anaerobic digestion, we're essentially digesting biological matter, turning that into water, plant nutrients, biogas, and energy. Now, those technologies have been in the European market for 15, 20 years. We don't have a lot of large-scale anaerobic digestion in the U.S. Some of the companies that are now coming in have maybe 1 or 2 locations here in the U.S., but the technology's been proven for 20 plus years over there. Same in pyrolysis. And one of the reasons is they have less land mass, they're more concentrated, they have to be more efficient. And so they've been focused more on sustainability just as a necessity than we have here in the U.S., where we have wide open space. We can go do whatever we want. We can throw it in the ground. It doesn't matter. Right. I've seen reports in the last few weeks that say, we've created something to the effect of 2 to 3 times the biomass that exists naturally on the planet. Wow. out of materials. So we've taken materials out of the ground and created garbage essentially, and other materials at a rate of 2 to 3 times of the natural environment. So that if you think about it, it's really non-sustainable. And so, we do really need to get to that circular type of economy. And that's where these waste to energy technologies become really interesting, because you can re-input that and, recreate it into another use potentially. Ultimately, we've got to get to biodegradable, got to get rid of plastics and everything else. But we look at some of those technologies because they can create clean, effective, 24/7 clean energy.
So let's segue back into Mavericks here for a second. So now, if we really, and so many different things going on here, and I mean, I honestly could spend hours with you here, and I'm sure we'll have many conversations. But let's talk now about because at the end of the day, your mission, if I were to sort of simplify it a little bit, is to, in essence, rebuild the energy grid, from the sort of outside in. Right, meaning microgrids kind of into the main area, and so the question I'm getting to is as you look at the current state of microgrids, both domestically and internationally, I mean, it just makes all the sense in the world, right? So, what is it besides consumer adoption that is slowing down microgrids themselves being propagated into the marketplace today? Is it just misinformation, or just people don't know?
Yeah, so it's, some of it's technology constricted. It has been, on the energy storage side, it's taken to this point where energy storage has started to become more cost effective. Some of the technologies are not out there. And it's sort of like solar was back in 2008, 2009, that it's fairly new and people don't totally understand it. Right. When we were doing solar back in 2008, 2009, we would go out and do like 5-6 Walmarts in a few weeks. And then I'd go talk to a commercial customer here in the Bay Area that was, maybe a small manufacturer. We were going to put in a 100 kilowatt system for his site. And he's, well, I don't know if solar works. And I'd say, well, we just went and did 10 Walmarts. It's working for them. So I know it's going to work for you. And they'd be like, oh, okay. And it's that's kind of how we are, is until we see somebody doing something, it's like, oh, okay, that makes sense.
Right. Totally. So, but I believe, given the emphasis on microgrids, and the concept, which is really, I mean, they've been around for a while, but they're starting to take hold. The term microgrid, that's why I was kind of asked you about it specifically, so we've got definitions for it. But honestly, people's homes can become microgrids. People themselves as consumers can decide, not only putting, I'm actually creating the stepping stone for the vision of replacing the entire grid itself, right? And my participation isn't just choosing to use solar, which, by the way, is honestly price per kilowatt commensurate with regular energy today, right? If not cheaper. Yep. But I'm also putting in the infrastructure that enables the transition to a new future grid, whatever that looks like, right? That's actually sustainable. So, I mean, to me, it feels like more of a PR game right now, a bit of a marketing game, just to get people to adopt.
Yeah, it is. But at the same time, if you look at what's going on just on the vehicle electrification side, if we don't put microgrid structure in, like for your home, for example, you could go in and let's say everybody in your neighborhood put solar and everybody got electric vehicles. That's fantastic. If you don't have that energy to storage to go along with it and the power goes down, now all of a sudden you don't have power for your home and you can't go anywhere with your vehicle.
Right. Absolutely.
And that's why microgrids are really critical, because the coupling, microgrid, essentially you're coupling the control, the energy storage, and the energy generation that allows you to stay online regardless. That's super critical when we start electrifying vehicles, because if you think about a police department.
Yep.
If a police department is not fully electrified, if they're fully electrified and they don't have their own grid infrastructure and they can't charge their vehicles and there's an emergency, they're sitting in the parking lot.
Totally.
So there's a lot of things that need to take place to be able to get to the point where what everybody's talking about on the electrification side. And, we just don't have the infrastructure to support what is coming over the next, 10 to 15 years.
And let me ask a sort of an energy supply chain question, right? So as of right now, we've been talking about renewables. Currently, you're focused on solar, which obviously makes a lot of sense. But as you said, I'm assuming you're agnostic to whatever renewable energy source might come along. Are there other energy sources that you're seeing in the portfolio? So the obvious one, solar, wind, thermal. I'm seeing a lot of stuff now with, I actually think it's gravitational energy creation, but, people talk about a wave, generator, which is really gravity at the end of the day, but I'll leave that aside. It's probably too science fiction-y for a lot of people, but I think for you get it. But I actually think we're moving towards a gravitational based energy generation system,
Yep.
but we're at the very early stage. So question is, what other renewable energies are on both here now and then on the horizon that you're seeing, right? That's interesting.
Yeah, I think the gravitational is interesting. There's one company that's essentially building large towers, and during the day they're lifting the weight in those towers up to the top, and then during the evening they release slowly, and that generates electricity. I've seen another one recently that is using like a rail car type system, where during the day they're pulling these rail cars up the hill, and at night they release them, and then they generate electricity slowly as they come down the hill. A couple of years ago, Caterpillar actually came out with a very large truck, that's in the mining industry, and what they're doing is I think it's like 1 megawatt of electricity to go up the hill, and it generates 7 megawatts as it comes down. So they're basically they're mining at the top, they're loading up that vehicle, and as it comes down, it's generating electricity that provides power to the site.
That's cool.
So there's a lot of things going on like that. We're actually working with a company that has a small turbine that can generate up to 15 kilowatt hours of electricity. It's like 8 feet tall. They have some proprietary technology around essentially the generator at the bottom, which is really a sophisticated alternator. It can operate in low as 5 to 10 mile an hour winds, and up to 70, 80 miles an hour without an issue. So there's some smaller technologies that we're seeing. When we look at like vehicles, just electrified vehicles, they're super efficient. As far as an energy usage, when you compare an electric vehicle to combustion, you think about combusting fuel, most of the energy in that combustion is actually going out through heat of the car. So you're not really generating a lot of momentum. In an electric vehicle, it's going from the battery to the motor to the wheel. There's not a lot of waste there. Microgrids are kind of the same as well. When we look at the grid of what's been built, centralized grid structure, you have a big power plant in one location that's pushing energy miles and miles and miles down that road. The loss of that energy can be up to 60% by the time it gets to the customer. Because what happens is you're pushing electricity through that wire. There's resistance in that wire, and so you lose energy in that process. When we generate electricity at the site, it's being used at the site. We're not losing it through transmission. It's much more efficient to be able to do that.
Right. Okay. So let's now kind of look a little bit forward with not only what you're doing. Actually, let me ask you a quick question. So one of the energies that and I just want your opinion on this one, is nuclear, right? There's been a lot. I see it. It's one of these energy sources that a lot of people get a little bit heebie-jeebie over, but it's changed a lot over 30, 40, 50 years. It's gotten a bad rap, in my opinion. I mean, I'll freely admit I have a bit of a bias towards it. How do you see nuclear coming in, or will it come back into the portfolio? Because, quite frankly, energy generation, again, to be blunt, I don't think anyone cares how energy is generated. If I could tell you that we could generate all the energy based on gravity, well, sure, let's just do that, right? But all these competing sources of energy generation are just that, right? I mean, if one became the one ring to rule them all, we'd use it. But we use all these different ones because of the inefficiencies or efficiencies or whatever the case may be. And nuclear is one of those that could be left behind or could be reintroduced. I'm not sure where it's going to go at this point, because it's right on that tipping point.
Yeah, I know, I know Gates and a lot of other people have been working and looking at that space. I mean, my thought is that if they could figure out how to essentially neutralize it at the end of its life cycle, I'm all for it. If we have to store it for 5 million years or whatever, then it's not really a sustainable, process.
Right.
But if they can figure out how to utilize it, and I know that there's some companies working on technologies that are, thorium or other based, where it has It's a much lower radiation level, and it's a much shorter life cycle. I think that that definitely has a future. Here in California, we have Diablo nuclear plant, and they've been talking about shutting it down for years, and it's actually scheduled to be decommissioned. Well, now they're talking about keeping it online because we don't have the ability right now to replace that energy. If everybody started putting solar on their home and storage in their home over the next 5 years, we still wouldn't be able to get to the capacity that Diablo creates right now.
Correct.
So we need to have the strategies around how to do what we need to do. And there's a lot of technologies out there on the energy generation side that are being worked on. There's also a lot of technologies on the energy storage side that are being worked on. We're really solar. So when I started installing solar in 2008, 2009, average watt panel was like 185, 190 watts per panel. 10 years later, we're 400, 500 watts per panel. So the efficiency and the density of energy that we're generating off of these panels has gotten much more efficient over time. We're going to see the same thing in battery technology. We're going to probably see some technologies in the next, 5 to 10 years that, had not even been thought of really. There's one company that we're talking to that is out of Australia, and they actually have a technology that you can retrofit a coal-fired power plant and make it burn hydrogen. So it's basically they replace the boilers within the power plant with a hydrogen-based boiler, and you can power that coal-fired power plant now on carbon neutral energy. So there's some things taking place in the space that are super, super interesting in being able to decarbonize energy. And we need to get there as quickly as possible. It was 80 degrees, I think 3 or 4 days ago here in Santa Cruz. It's December. It's right. Relatively nice typically, but it shouldn't be 80 degrees.
Right. I hear you. So again, I'm just looking at the clock here. I want to be conscious of time. These things go so quickly. You blink and all of a sudden an hour's gone by. So like I said, I know this was going to be a healthy conversation. So just parting thoughts, things that you think, are out there sort of in the future, whether it's prognostication or just in the current sense of what's going on, things, maybe some of the things that people don't realize, whether it's at Mavericks or just in microgrids or microgrid technologies. I mean, what do you see kind of coming up in the future here?
I think the microgrid space and the virtual power plant space is in 5 or 6 years is going to be the same place where solar and storage, is perceived to be right now. To be much more scalable. Many more companies will be doing it. And it's going to be more of a, kind of a plug and play type of a scenario, similar to where the solar is right now. So it's going to be more scalable. I mean, I think that power is super interesting right now, can be democratized. And the reason being is like what we talked about is in some cases, we're producing more solar than we can use.
Yep.
And, when you get to a massive scale, what that ends up looking like is you can sell power super cost effectively and very low cost. One of the groups that we're working with is actually doing microgrids in Africa. They're going into communities that there's no infrastructure, there's no power, and they're starting to set up microgrids in these communities. And so what we really see in the microgrid space is it following the same path that the telecom did, where mobile phones went out and they globally expanded much quicker than the old infrastructure of telecoms did. Microgrids are going to start doing the same thing, where you're going to see microgrids in all these different markets, in all these different spaces. They're going to leapfrog the traditional utilities and the traditional infrastructure that's been built over time.
Awesome. Well, listen, Bill, as I said, hour flies by. Incredible conversation. The work you're doing in the microgrid space is super interesting at Mavericks. Where do people find out what you're up to besides LinkedIn? I mean, I'm assuming you're open for a connection. Yeah. You
can go to mavericks.energy and check us out. We just have a landing page there right now, and then find, Bill Shevlin on LinkedIn and, I'm happy to talk to anybody. And, I really appreciate your time, Richard, and what you're doing. Making people aware of all these different issues is important.
Well, and I apologize because I was going to do this on LinkedIn Live today. But maybe do it the next time. But I'm also trying. I mean, these conversations, are really the foundation for a lot of the change that's happening, and bringing people like yourself together, thought leaders in the space. I think has a huge impact. I mean, I've seen it personally in the area of data centers and what we're able to do and the efficiency gains that we had there. And now we're just trying to bring this into the supply chain energy kind of space as well. So awesome. Well, listen, really, thank you so much. Great conversation today. You have a wonderful, wonderful day.
You too. Thanks, Richard.
This is Richard Donaldson. Thanks for listening. If you have any comments about the episode or topics in supply chain you'd like us to explore, we'd love to hear from you. You can reach us at supplychainnext@requis.com. And while you're at it, why not check out the Requis platform at supplychain.requis.com. Requis allows you to manage the full asset lifecycle in the cloud, collaborating with your entire value network to buy, manage, and sell your assets. Find out more at www.requis.com.